Hey there everybody, my name is Chili. Welcome back to Beginner C++ Tutorial 5. Today we're going to talk about comparison operators and Boolean operators, just a shit ton of operators. Now up until now we've only been dealing with the addition, the subtraction, and the assignment operator. And while I am going to introduce a whole bunch of new ones, they mostly operate similar to each other. It's the same shit, different pile. So it shouldn't be too hard to pick up. Now this is the kind of application that you should have gotten if you completed the homework. You've got this cursor and you can control its speed, move it around, and oh fuck. And as you can see, you go off the screen and it's a bad time. The homework made it a little easier to control, but it's still not the best. And you don't want to give the user any way to get their dick caught in a ceiling fan, because if there's a way, they will find it. Just try and stop me. I'm going to get my dick caught in that ceiling fan, if it's the last goddamn thing I do. Now you may have wondered why it is when you go past the right hand end of the screen, when you go off the screen in the X direction, it doesn't crash. It crashes when we go down in the Y or up in the Y, but why not in the X? And the reason is because the way it works is if you try to draw the pixel off the screen in the X direction, it's just going to wrap down to the next line by that many pixels. That's the way it works. That's the way the pixels are laid out in memory. And we'll get into more of that when we learn about arrays. But for now on, you just don't have to worry about it. Just know that your program's going to crash if you go off the top or the bottom, and the pixels are going to wrap down to the next line if you go off the sides. Now, one thing you can do when you're working with your project is you can set the configuration. Now, there are two configurations, debug and release. And we've been in release so far. But if you set it to debug, it's going to build the solution a little bit differently. And what it does, well, it does a bunch of things, but one of the main things it does is it adds in extra safety checks or sanity checks to make sure your code isn't doing anything stupid. So before, when you went off the side of the screen, it would just wrap. But now if you go off the side of the screen, immediately you get assertion failed. And you're going to get a little bit of a hint here as to why you had a problem. So here is the test that failed, and it was x greater than or equal to 0. So if we try to draw off the screen, do a put pixel to an x coordinate less than 0, you're going to trip this error, this assertion. And we'll talk a little more about this assertion bullshit when I introduce the debugger. So what we want to do is we want to make sure that the user can't put the cursor off the screen. Now to do this, we're going to want to basically make an if statement. So we want to do an if statement kind of something like this. Now the problem is, how do we determine if the cursor is too far to the right? So far, the only things that we can tell about are, if a certain key is being pressed, but we don't have any function to tell us if we're off the screen or not. What we want to do is compare x with some value, the limit of x to the right, and if it's greater than that limit, then we want to set the cursor just to the safest right position. But we can't. We don't know how to do that. Right now, the if statement we're using, it doesn't have its balls. So let's give if its balls back. Let's make if great again. Now, comparison operators work similar to, say, like an addition operator, in that it takes two values, two operands, left and right, and it poops out a result. Now, it's a little different in that, for example, the greater than operator, it takes an int on its left and an int on its right, but it poops out a bool, so the result is a different type than the operands. So the way the greater than operator works is if the left operand is greater than the right, it poops out a true. Otherwise, it poops out a false. Very simple. Let's try a few examples. All right, 420 less than 69. What is the result? It's obviously false. Negative 30 greater than negative 60. What do you think this one is? This one is true. And you might say, well, Chili, 30 is not greater than 60, but this is negative 30, right? So negative 30 is more positive than negative 60, and therefore it's true. Now, this comparison operator checks to see if the two values are the same. Don't get it confused with the assignment operator. This is the equivalence operator, or I just call it the equals operator usually. But you can fuck yourself over really hard by getting these guys mixed up. Don't do it. So what's this one? 20 equals 20. That is obviously true. What are you coming at me with this Bush League bullshit? Pizza greater than burger. That's a trick question. The answer is actually pizza burger. Alright, final question, double or nothing. Hand job from Jonathan Blow greater than blow job from Jack Handy. Honestly, this is one you guys have to answer yourselves. You gotta be the judge. I don't want to kink shame anybody. Now you can combine the greater than and the less than operator with the equals operator like this. So for example, 79 greater than or equal to 79, that's true. 80 greater than or equal to 79, still true. Now, one last very useful comparison operator is the not equals operator. And this one returns true if the operands are not the same. So it's the opposite of the equals. All right, so let's turn this pseudocode into pseudocode. That doesn't make any sense. X. If X is greater than, and you might remember me saying that the furthest right pixel that we can write is 799. So if X is greater than 799, we're going to set X equal to 799. And that should work, right? Because, I mean, if it ever goes past the maximum, we set it to the maximum. Yeah, let's just try that. Nope. Assertion failed. We fucked up. Okay. And of course the reason why is because X is the center of the reticle, but the actual pixels are being drawn around that. So the actual pixels can exceed the value of X. So what we want to do is we want to compare X plus the distance from the furthest pixel in the X direction, which is going to be, this is the pixel that is the furthest to the right. So we want to compare X plus 5 and see if that's greater than 799. And if it is, then we want to set it to 799 minus 5. And that will set X to the spot on the screen that makes the rightmost pixel be at 799. Now you can use hard-coded values for the width like 799, but a sexier way of doing things is to use graphics.screenWidth, and this just directly gives us the screen width. And the beauty of this is if we change the resolution of the screen, the code will still work. Whereas if we had hard-coded it and we change the resolution, the code will become broken. So let's do the same thing for the left and the top and the bottom. And if we do that, we should get something like this. And we're just going to build it, run it. And now if I go over like this, bam, still failed. Well, fuck me. Now the reason for this is that screen width is actually equal to 800. It's the number of pixels across. So what we want is we either want to subtract 1 to get the index of the rightmost pixel, or we could just set this one from a greater than to a greater than or equals, and this will include now the value of 800, which is one of the values that we want to change. And here we have to set it to screen width minus 6 because it's got to be 1 less. And we'll do the same for the Y, setting greater than or equals and subtracting by 6 instead of 5. And now this should work fine. And there it is. Now you might notice that your cursor gets stuck there on the right hand side and you have to keep pressing. And that's because even though it looks stopped, it still has that velocity moving it to the right, and you have to counter it by pushing a lot in the opposite direction. So generally when we see something stop, we would assume its velocity has become 0. So let's also change Vx equal to 0 and Vy equal to 0 for these guys. And if we build and run that, now when we hit the edge, we can immediately start moving in the other direction like this. Beautiful. All right, so say that this is the screen. And now what I want to do is, if the cursor is inside some kind of strip here in the center of the screen, I want it to change color. So how am I going to do that? Well, if you want a good challenge, then stop the video and try to code so that the reticle will change color when it's inside some central strip on the screen. Did you get it? Well, here is the answer. What you got to do is you got to check to see if X is, for example, less than this position here, and also check to see if it's more than this position here. And if it satisfies both those conditions, less than this, but more than this, then it's within this region. So how do you check for two conditions? Well, you can use the thing that I told you about before. We go if X is greater than 200, and then inside of that if statement's control block, we put another if. We nest that motherfucker. And if X is also less than 300. So it'll only do this test if it satisfies the first one. And if it satisfies them both, then it'll do whatever is in here. And I'm just going to reuse control is pressed because I don't want to type out a bunch of bullshit again. So we preset it to false, and then we only set it to true if it satisfies these two conditions every frame. And then that'll change the color of the motherfucking thing, whatever it is. Reticle or targeting box, don't matter. So see, oh wait, control it wasn't controlling the color, it was controlling the shape. Well, you get the motherfucking idea. Jesus Christ, I mean, come on. So yeah, if we want it inside that region there, we nest our ifs. Now, what if we wanted it to change if it were only outside of the region? So we can do something like this, where, again, it defaults to false, but if it is less than 200, it goes to true, or if it's greater than 300, it also goes to true. And this will set it, it'll change the shape when we are outside of the region. Inside the region, normal shape, outside, changed shape. And it's really just two different ways of doing the same goddamn thing, but that is another thing that you can do. Now, why am I showing you this? Well, because there is another way to skin this cat using only a single if statement, not these double parallel if statements or nested if statements. So these operators are the logical operators, and the way they work is they allow us to combine Boolean values and create more complicated reasoning structures. They both take Boolean values and the result is a Boolean value. And here is the table, because Boolean values only have, two separate values. I can show you a table of every single possible combination. So for an AND, the only way a true comes out is if both of the operands are true. Otherwise, always false. So it has to be A and B in order for the result to be true. Now, the OR operator is a little more loose in that you can get a true out of it pretty easily. As long as at least one of the operands is true, the result will be true. The only time you get a false out of an OR is if both of the operands are false. Now, this is a little different than the definition of OR that you're probably used to in, common parlance, as they say. Imagine you're on a desert island. You and Steve are on a desert island, okay? It's a pretty shitty situation. You're probably both gonna die. But you got these two kick-ass sandwiches. You got like a fucking turkey breast sandwich on the one hand and a nice pastrami on rye on the other. And you're like, okay, Steve, you know what? I'm a nice guy. I'm gonna let you pick which of these sandwiches you want to eat. You can eat the turkey sandwich, or you can eat the pastrami. And you know what Steve does? What is he gonna do? Does he go up and grab both sandwiches and shove them down his throat? I mean, fuck Steve, what the fuck you doing, man? Jesus Christ, Steve, you motherfucking pig. And then you go and you wrestle him to the ground, and you know when a dog eats something bad for him and you gotta make him puke it up, you gotta put your finger down their throat. That's what you're gonna do to Steve. You're gonna put your finger down and spit it out, you motherfucker, you fucking pig. I don't want to eat it anymore, but I'm damned if you're gonna get it. What I'm trying to say is, like, when you tell someone A or B, generally they mean either A or B, but not both, right? But in C++, A or B means A or B or both. Anything's good as long as it's not neither. You gotta give me at least one. Come on here, work with me. So AND is true only if both operands are true, and OR is false only if both operands are false. That's another way of looking at it. So how does this help us with our code? Well, we can take something like this and we can go yoink, delete that, jam a logical OR between there, and now it's going to evaluate this comparison, create a Boolean, going to evaluate this comparison, create a Boolean, and if at least one of those is true, then it'll execute the code. If not, if they're both false, then no dice. And if we run this, we see that it works. If it's outside of the region, get back in there. It's outside the region. If it's inside the region, normal. Outside of the region, we get some funky action. We get some box action. Give me that sweet box. All right. And the same is true. If we make it an AND, it's going to do, you know, the thing we had before, where it has to be inside the region. Wait, that doesn't make any sense. All right, I fucked up because, I mean, obviously it can't be less than 200 and greater than 300 at the same time. That's fucking retarded. So it's got to be greater than 200 and less than 300. And if we do that, now we got some dice. Now we're in the region. We get our funky box action. Sexy times. Beautiful. All right. Now, the final operator that I'm going to tell you guys about today is the Boolean Not Operator. And what it does is it just flips the value of a Boolean value. So if the input is true, it becomes false. The result is false. And if it's false, it becomes true. Now, this is different than the other operators that we've dealt with because this is an unary operator. I think I've pronounced that right. I don't know. Whatever. In that it only takes one operand, and the operand is the thing to its right. So it's not A and B or something. It's just not something, not A, not whatever is on the right-hand side of this. And it just flips the Boolean value of that. So what you can do is you can flip an expression like this. You can go not and then some expression, and then it'll do the opposite of what it was doing before. So now it's changing the box. It's changing to the box everywhere except in the region, which is the exact opposite or the complement of what we had before. And one thing I just want to mention is that these brackets are very important, especially when working with things like the not operator. Because if you don't put the brackets in, this operator is only going to work on the x value, the thing to its exact right. And that is not enough. We want to take the logical not of this entire expression, not just the x value. I mean, you can, it's kind of dumb, but you can take the logical not of like an integer. But it doesn't make much sense, does it? It's just stupid, so don't do it. What you want to do is you want to surround with brackets the entire thing that you want to flip the value of. And we'll be using brackets a lot. They help us determine the order of things that happen. So we definitely want it to first calculate these comparisons, then calculate the logical and then flip the value. Flipping the value is final and applies to this whole expression, or the result of this whole expression. But anyways, that is logical operators in a bag and comparison, all that good stuff. And now it's time for the homework. So for the homework, you're going to be drawing two boxes, just like the targeting box that we had before. And that's fine. You can move one of them. The other one is going to be stationary. The only catch is whenever the boxes overlap, the color should change. So you have to detect when two things are overlapping. Now, this is a super important calculation that has to be made in games, because obviously this is when you want to tell when two things are colliding. This is the collision. You check if their boxes overlap each other. And that is what I want you to do. You have all the skills you need to do this now.
Just do it!
That'll about do it for this lesson. Good luck with the homework, and I'll see you soon with the solution.